Good afternoon, everybody. Today is my pleasure to introduce my colleague, Professor Assad Khattak, who is the speaker for our CR2C2 seminar. So today's talk is about a framework to assess the readiness of intelligent mobility technologies. Professor Khattak made my job easy and very brief bio. He was humble to provide me a very brief bio, but go ahead and check the bios and a lot of achievement that he has made in years of research in transportation, different aspects from the planning to the technology and other aspects. But brief about him, Professor Khattak is a Beeman Distinguished Professor at Civil and Environmental Engineering at the University of Tennessee, Knoxville. He serves as the coordinator for the transportation group in the Department of Civil Engineering at the University of Tennessee. He's the associate director for the National Center, which is based at UNC Chapel Hill, and associate director for that center. Professor Khattak's research focuses on innovations related to intelligent transportation technologies, safety, and sustainable transportation. He has received his master and PhD in civil engineering from Northwestern University. He serves as the editor of the Journal of Intelligent Transportation Systems. With that, please join me to welcome Professor Khattak, and the stage is yours. Thank you so much.
Thank you so much. Greatly appreciate the invitation and being here. It's been about maybe 25 years before that I came to the campus when I used to teach at Chapel Hill, and it was we collaborated with faculty here back then, and I'm so pleased that we are still collaborating with faculty here. So, many thanks to Ali and his team, and that's why I have this CR2C2 here on my slide to kind of thank him and also our colleagues at all the other consortium universities for their kindness and their support and their willingness to team with us in this important endeavor, which focuses mainly on kind of an unexplored area, which is the rural areas. So I'll talk a little bit about the project I'm involved in for the CR2C2, but before that, I wanted to present this paper if we started looking at and a lot of other research that we have done over the years, looking into looking into ITS and also sustainability issues. So before that, I thought I'll ask a quiz question. Who are famous people that are associated with Tennessee? If you can name 3 of them, that would be good.
You saw
I showed you a picture of them. So in Tennessee, we like to, I guess we like the song, and we like the whiskey, and this is Elvis and Jack Daniels and Dolly Parton, and they are famous or made Tennessee famous. By the way, I was curious how Jack Daniels looked like, and this is how he looked, at least on internet. So the thing is, we come from I come now from a state where these are popular figures. Now, we developed this framework as part of the Tennessee Department of Transportation sponsored study, and basically presented this at TRB, where we had colleagues from Illinois and other universities also presenting somewhat similar kind of frameworks. So I'm very happy to show that we are able to at least think about at the Department of Transportation level about intelligent mobility strategies. Now, what we thought about how to structure this, and as you can see here in this diagram, we thought that going forward, electrification and clean fuels is a very important area to cover within a framework. Also, connectivity and automation, of course, is very important, but also looking at the infrastructure and especially smart cities is another key element that we want to have in our framework. Safety and cybersecurity have emerged as well, safety was always important, but cybersecurity has, because of our digital infrastructure that we have, it has emerged as a critical area. Of course, we need to have policy and regulations updated with automation, especially if the people are not going to be driving themselves, but the car is going to drive them. Then we need a lot of legislation for testing and for looking at how these can be implemented relatively quickly. And also public acceptance. People are not so comfortable with these vehicles. So that's another key element. So investments in the future of this mobility, I think, involves the kind of a statewide perspective and support and impact, and also partnerships as well between industry, academia, as well as the private sector and public sectors, workforce development. And as you can see here, we think engineering, planning, and data modeling, simulation, visualization, and artificial intelligence are the enablers of this technology. So intelligent mobility, in a nutshell, has been expressed as ACEs, that is automation, connectivity, electrification, and shared mobility. So the study that we did for Tennessee DOT was with the aim of assessing the readiness of emerging mobility technologies using a novel framework, which I just described. And we also conducted a survey of the stakeholders as well as ITS data that we could get from different entities, especially from the folks that collect such data. And we do have ITS architecture plans for even relatively small cities, which were very helpful. So the concept of ACEs is that automation and connectivity, these are two somewhat different things. If you think about it, we can have full automation of the cars, but they don't have to be connected with the infrastructure. Google Car is one example. They try to not necessarily, at least to my knowledge, they are not connected completely with the infrastructure, or even partially with the infrastructure. The connectivity that between roadways and the vehicle, as well as vehicle-to-vehicle communication, is indeed a separate part. So whenever you have an automated vehicle, it can do much better often with connectivity. Okay, if it gets information from the infrastructure and passes that information about its own performance to the infrastructure, that is where you can have an even much bigger impact. At the same time, as you can see, Tesla, for example, has been able to combine automation with the electrification part, and that's this part here. And then Uber and Lyft and other companies have obviously provided robo-taxis in recent years that are able to carry folks around within certain domains. That is, they are able to operate without a driver in these domains. So this not only applies to the movement of people, but also of goods. The framework that we have, in the sense that these cars can be replaced by large trucks and vehicle-to-vehicle communication and automation of trucks. It seems like is probably more easier to do in some contexts. So I won't go into the details of this ACES framework that we developed further, but basically we had a survey and we presented this work at the Transportation Research Board, where we looked at a household survey and we looked at the perceptions of people, and we had four critical, well, actually in this case, maybe three critical variables. One is this early adopters, and then there is also the willingness to purchase automated vehicles up to level 2, and automated vehicles that are self-driving, that is level 3 or more. As you know, there are several levels of automation. Level 3 kind of starts to depart from you being the driver to kind of like an automated driver. And we looked at also the perceptions in car share programs. So what we found was that, about EVs, and things are kind of accelerated, but then now they are kind of, seems to have decelerated on early adopters or early ownership of electric vehicles. And we found that a lot of people thought that they were too expensive. People didn't have knowledge about the technology itself. Also, technology is new, unreliable, lack of charging facility, battery life uncertainty, and also some of the issues with range anxiety and so on reflected here. So this is a framework which is called path analysis, and you have several dependent variables in this case, and you're trying to understand the relationships with these independent variables, which could be household characteristics or perceptions. And what we found is that, certainly safety concerns are big when it comes to high levels of automation, and sometimes people who are more willing to experiment and participate in car share programs or are early adopters of EVs are also more likely to purchase high levels of automation vehicles. So these are some of the results that we found. In addition, we did a survey of folks in our state coming to the concept. What we tried to do is we tried to give them a lot of stakeholders, private sector, universities, and also public sector, Tennessee Department of Transportation, for example. Here we had intelligent mobility readiness was assessed through these survey of stakeholders, which we had to design in such a way that it had to have a very focused kind of questions, but they also were explaining to people what we meant by those questions, because a lot of the issues involved require explanation. For example, the design domain is not always very clear to people. So we had to explain all that. So the participants were diverse, and it included all these, fleet manufacturers, as well as operators, as well as Oak Ridge National Lab scientists, and so on. And we were trying to identify intelligent mobility practices and assess Tennessee's intelligent mobility readiness. So we designed the survey in such a way that we said, okay, what is the expertise that you may have in these physical infrastructure, digital infrastructure, electric vehicle infrastructure, and public knowledge and acceptance? And we didn't ask about policies because those are somewhat controversial issues. So that's a separate piece of work that we've done on policy and regulation. The questions we asked were, I can't go through all the survey, but it was to say, for example, has your organization researched, developed, or deployed pavement markings, improvements, or any technologies for connected and automated vehicles to clearly detect pavement markings, for example. And then they could answer on this 5-point scale, yes, no, but we have a specific plan for it, no, but we expect to have a specific plan, no, we have no plan for it and don't know or not applicable. So so what we did was, we can start with this simple one here, which is easy and intuitive to understand. So if you are at level 1 on technology, you are people said we don't do this in any sense to maybe physical infrastructure. We are not doing much on that. We are not doing much on digital infrastructure. Level 5 obviously means that we are doing more on that. We are pretty much up there, just like if they said yes here to this question. There were several questions like this, and that report is available online. So we used certain percentages for readiness. I won't go into the details of how we coded the data and so on, but ultimately our aim was to look at and find readiness. What we found was that the electric vehicle infrastructure, because of the US DOT policy on improving our electric vehicle infrastructure, it seems like the state had done quite a lot of work, and also the private sector had anticipated a lot of work here and put in expertise on that. So that was one of the highest ones that got the highest score on readiness. And the public knowledge and acceptance ranked the lowest when we looked at the results. And this can be improved by informing public, obviously, about existing and emerging intelligent mobility options. So I've simplified things, but these are the more detailed questions that we asked about physical infrastructure, like ability of CAVs to detect pavement markings. Have you worked on road sign improvements that would help with identifying CAVs? Similarly, we can look at digital infrastructure. So do you have CV2X communication technologies that you have employed? CV2X are technologies that are being deployed as roadside units, for example, or in-vehicle units that are able to communicate between cars or with infrastructure. Are you collecting, managing, and using real-time traffic data or not at the state level or by the private sector, so on. Similarly, for electric vehicles, we had questions about electric vehicle charging and also expanding the number of EV charging stations and so on. And for public knowledge, we had these questions about, informing public about automation in the freight industry. Have you made any efforts there? Share barriers to CAV adoption with the public and so on. So those are the questions we asked, and these are the subcategories of those questions that we asked. And what we did was we tried to analyze, and I think this would be very useful for a state to do. We looked at the correlation heat map between key intelligent mobility areas. There's a artificial intelligence technique called T-distributed stochastic neighbor embedding. This is a technique which helps you understand the correlations between the variables that I was showing you and saying, whether private sector or public sector or what particular company has more expertise in this area versus another area. So this provides a rich landscape of interdependencies among physical, digital, and electric vehicle infrastructure, and also public knowledge and acceptance dimensions of this. So I won't go into the details of this, these numbers, but they provide you with a heat map of, if you put in the public knowledge and and also some infrastructure. How well are those strategies correlated with each other? More interestingly, perhaps, this technique, like we said, is well suited for what we call dimensionality reductions. When you have a lot of variables, you can use this, and it's especially with high dimensional data sets, by observing the clustering of data points and then the visual exploration. So, for example, in this case, for the physical infrastructure, we can say, okay, the private sector or the universities say that they don't have any relevant information, or they have a lot of relevant information. So this is highly relevant, this is not relevant, the red one, and then moderately relevant is green. So in a dimensional space, you can have this as one of the ways in which you can analyze the data. For digital infrastructure, the landscape is a little more, diverse, as you can see, and also in the public sector entities, there's wide dispersion that is on the electric vehicle infrastructure chart. And they are indicative of different levels of investment or initiatives across various public entities. So certain entities like Tennessee Department of Transportation was very interested in and did have expertise, developed expertise on electric vehicle infrastructure. Similarly, there was a lot of spread, but universities in terms of public sector, they were looking at public knowledge and acceptance, and also the public sector, and we can get into the names of the firms and so on, but for just this presentation, I thought it's better to just have them as kind of generic, and this may reflect the influence these factors have on public opinion and acceptance of new technologies. So the public sector was more concerned, and the universities were more concerned about informing the public and had expertise about informing the public. Shifting the gears a little bit was this ITS architecture data that we were able to collect from different cities in Chattanooga and assess whether, these are some objective measures that cities have used, and I won't go into the details of it, but basically, as you can see, the larger cities like Memphis and Nashville exhibit higher levels of readiness than small and medium-sized cities in terms of the criteria that we mentioned. This included the policy and regulation part as well, the physical and digital infrastructure, and smaller cities seem to need more investment for the infrastructure. That's what our conclusion was from looking at the data. Of course, we have a lot of limitations that the survey excluded policy and regulation, which is a complex and multifaceted domain involving various stakeholders. So that's an important step where we need to try to understand the regulatory environment. The traffic management centers and CAV readiness was excluded as well from the survey due to length, and the stakeholder scope can be expanded, of course. TenSmart is a consortium, and we were looking only at the consortium members. It's a pretty diverse and good consortium, but certainly this can be replicated in other states, and the sample size can be larger. The key takeaways were that electric vehicle infrastructure is the front runner in terms of readiness, but the digital infrastructure ranked maybe lower, and it requires more attention, especially when we looked at those objective measures and smaller towns and maybe rural areas. The physical infrastructure provides us with more levels of readiness, and public knowledge and acceptance ranked the lowest. So this shed light on differences between larger and small, medium-sized cities. Memphis, Chattanooga, and Nashville relatively high readiness, but other cities were not. So the key takeaways were that the strategies that we could use include establishing and supporting connected and automated vehicle test beds, smart cameras, fiber, CV2X technologies, also CAV data, and dashboards. So there are some field tests going on at the federal level. One is in Tampa, one is in New York, and one is in Wyoming, and they have developed good sense of how to collect the data and display it and look at it. So our reports looked at those and provided some guidance on how to do this. Also, zero emission vehicles could be considered as a policy and by the state, and EV parking areas and workforce development came out as well, important aspects, and so was stakeholder involvement. We also found that in comments that people said that unintended consequences like job losses in some sectors, especially for drivers of commercial vehicles, was an important issue that we need, societal issue that we needed to address. And this would need some strategies, for example, like collaborative approach to mitigating the problem, and also for state DOTs to utilize the framework to assess mobility technologies readiness and identify investment prospects. So this is the report that we have online. It's 5 parts of this report. This is what I presented was just part of one of the reports. It's fairly extensive. So I want to pivot a little bit and look at some of the research that we have done, which will help us understand what we've been doing in terms of looking at disadvantaged communities, rural areas, people with maybe who are not as advantaged as other communities. So we just recently published this paper, which is pretty highly cited. I get these alerts about, okay, your paper is highly cited. So it makes researchers feel good. So I'll kind of discuss some of that. And also we have several other initiatives going on in this area. So just looking at how we can understand the disadvantaged communities. And the background of that is that there is this national roadway safety strategy, which has these core objectives of having safer people, safer vehicles, safer speeds, safe roads, and post-crash care. So the US DOT initiatives are resolving disproportionate safety impacts for people and of different colors and minority groups, and looking at disadvantaged communities as part of our framework was very important. So we got some data on DAC, the disadvantaged communities. We integrated that with crash and inventory data to understand transportation safety in DAC. So, this information is pretty well known in the sense that the fatal crashes in disadvantaged communities tend to be much higher per 1,000 population. So as you can see here, it's about 90% higher than you can call them advantaged communities. Also, as you can see here, fatalities are higher. So fatal crashes can have multiple fatalities. So it's kind of a little different, but they're somewhat similar. So this is also, as you can see, pretty high at 90 to 92%. Okay, so we have several articles using this data that I'm going to talk about on disadvantaged communities. We've presented a lot of this work at TRB, and also, like I said, published it in Accident Analysis and Prevention and International Journal of Sustainable Transportation. we just had this article accepted on alternative fuels in disadvantaged use in disadvantaged communities. I'll talk about that a little bit. Also applying artificial intelligence techniques to examine nighttime pedestrian crashes. Actually, this is a North Carolina study. We have very good data on pedestrian and bicycle crashes here, and also looking at urban farm demographics and disadvantaged communities. So this looking at pedestrian bicycle, and also survival time analysis, doing analysis of how long people live when they do get into crashes in advantaged and disadvantaged communities. So the US Department of Transportation has released a database which has these elements. It's called transportation disadvantage, equity disadvantage, environmental disadvantage, economic disadvantage, and health disadvantage, as well as resilience disadvantage. So each one of these is a set of indicators. For example, for health, for environment, they are saying, well, the percentile of, let's say, particulate matter 2.5 in air, if you have bigger particles in the air and their concentration is high, then that can be an environmental factor that influences our health. So that's bad. And the percentile of ozone or other toxins that cause cancer and so on. So, this is one example of how they use different variables to capture these concepts, which is transportation disadvantage and so on. So for each one, we created a map, but there's also overall disadvantage. If a person was disadvantaged in 4 out of 6 categories, then, not a person. In this case, it's the census block. So if the census block was disadvantaged, then we said, okay, those are overall disadvantage. Okay, so this is how the map of the United States looks like. Now, subsequently, the US Department of Transportation has improved this, and they have reduced the number of indicators to 5. And they have also expanded the transportation into 2 other indicators. One is called transportation access. Like, as you can see, the person doesn't have, or household doesn't have personal vehicle, then this, they would be considered as not having access, or they cannot, or they have very long commute time or something. And then there is the transportation cost burden indicator, which is looking at, okay, this person has a lot to pay for the cost of the fuel, for example. Similarly, there are other indicators that are clearly now shown in terms of transportation, in terms of vulnerability and health and so on. Okay, so this graph, what they do is they normalize these, and they kind of so that they can be added up, and then you can get an overall indicator as well. So in our analysis, what we did was we imported crash data on looking at fatal crashes, and we combined it with this justice data. And then we estimated what we call hurdle models. These are basically models that are able to account for whether or not a region had a fatal crash or not. And in this case, that region is basically a census tract, which is pretty small. There are about 85,000 census tracts across the US. So it's these models are able to account for excess zeros. Sometimes you get this problem that there might not be that many fatal crashes in a certain geography. But what we found was that this disadvantaged indicator, if you took the 50th percentile, which is a pretty loose way of analyzing the data in terms of disadvantage, then you still see that environmental disadvantage, well, that's not statistically significant, but the health and resilience and transportation disadvantages, people who live in these zones have a much higher fatality rate. They also, this becomes significant when you use a tighter filter and you say, okay, 85%, we're going to use 85th percentile to remove, maybe disadvantaged communities that are very highly disadvantaged from other communities. So basically, there we find that these other indicators, this other indicator of environment also becomes statistically significant, which is indicated by the Z statistic or the p-value here, which is very low. So, and we also found that race and ethnicity, for example, American Indian and percentage of Black population does have an impact, and it does show a statistically significant increase in the number of fatal crashes. We did this also in another study that we are still doing. We looked at these indicators as well and found that this, well, let's look at, we said, the fatal pedestrian and bicycle crashes. Well, actually, this is only pedestrian. Well, sorry, but ped bike. So we looked at that and found that it does have a very strong impact. All these indicators do have a small impact. We controlled for many other variables that typically influence the number of crashes in urban areas, but this is well, urban or rural areas, but basically we were able to capture these effects while controlling for, let's say, means of transportation to work and other variables like alcohol consumption and so on at the census tract level. So that's an important finding when it comes to more nuanced way of looking at disadvantage, when you're looking at health disadvantage, resilience, and so on. Those are things that we need to look at in more detail. In addition, our study, this is the paper that I was mentioning, it's been published in Accident Analysis and Prevention. You clearly see that minorities are at higher risk of crashes, especially Hawaiian or the Pacific Islanders, and also American Indians, and also maybe Hispanic and Black folks. So that's what we found. We are also doing so there's a concept called spatial heterogeneity, whereby they say that, maybe even though something may appear very similar, may have a similar effect, a variable such as, let's just take alcohol consumption, may have a similar effect across all jurisdictions, or it may have a different effect in different locations. So we were looking at that and seeing, are there spatial variation in terms of these parameters, each of these parameters that I was showing you here. Is there, like, if there's a health disadvantage zone, then is there, does it vary across geography? And what we found was that, yes, it does. There's a lot of variation. We are still doing this study in more detail, but basically we found that, yes, if you have a disadvantage, in this case, we are just showing resilience disadvantage and its variation across the disadvantaged communities. So, and also we have transportation disadvantage here. The other study that kind of used a similar data, but we combined it with a travel survey, was from Seattle. So we combined the Justice 40 data with the data from behavioral data from Seattle. And we were able to look at the number of charging stations and its effect on disadvantaged versus advantaged communities. Okay, and as you can see here, the interesting part is, and I'll be happy to share the paper with you. It's forthcoming in this International Journal of Sustainable Transportation, but a lot of detail there. But notice that adding one more charging station in disadvantaged community does have a bigger impact in terms of probability of adoption of alternative fuel vehicles. Okay, at least that's what we found in Seattle to be the case. And this is one of the studies that we have presented at TRB as well. And we think that, there's a lot more we can look at in terms of what other measures to use, like in addition to auto ownership. But this is what we found so far. Okay. And then one of our students is looking at North Carolina pedestrian crashes. So, people have looked at this for a long time, but we are looking at it from this DAC perspective lens. And we are looking at the PBCAT data, which PBCAT is a tool, pedestrian bicycle crash analysis tool, that gives you a very good coding of police reported data. They kind of go in and report the data, looking at the type of crash and how it happened and so on. So it has many more richer set of variables. We combine that with this disadvantaged community database for North Carolina. And I have to thank Highway Safety Research Center and also North Carolina Department of Transportation, Mr. Carter, who shared the data with us. And we've been analyzing this, and I just wanted to present some results where we found that economy and transportation disadvantage indices do increase, are associated with higher injury severity. Here we were looking at injury severity in addition. So not just looking at fatal crashes, but also the whole spectrum of injury, and from this very rich lens. So this is a paper that we presented at TRB, and we have this year, and we are still working on it. But as you can see, rural areas in particular have very high incidence of such crashes and higher injury severity given a crash, in addition to this disadvantages that communities have, and then also inadequate lighting. So these are all kind of related to each other in the sense that inadequate lighting is reflected more in disadvantaged communities. Also alcohol impairment is reflected in such communities as well. So there is this issue of, okay, really what is causal and what is not. We are also looking at mental health issues. So this year in TRB, you can watch this video here. People talked about, in fact, the Secretary of Transportation in the panel beforehand talked about suicide rate. So I had become interested in suicide partly because I was looking at crashes at grade crossings and then non-crossings. And they said, well, maybe 20% or 30% is people, who are committing suicide, which is very different. So that's a security issue, as opposed to a safety issue where the harm is unintentional as opposed to intentional harm. So this rate is becoming higher and higher. Every year, there are about 1.7 million adults that want to commit suicide, and then 50,000 last year were successful. And so it's a huge cost. And some of this is related to transportation, like I was saying, partly because some people do get killed in through transportation, but at the same time, I think what the TRB colleagues were saying was that the construction industry has the second highest suicide rate in the country, and we need to look at that as well. So there are these different complex angles which starts to go into more societal issues, but they are related to the profession of transportation, or transportation becomes the means for people to be to kill themselves. So unfortunately, very sad thing. But I thought we can look at, and we are looking at using this database of USDOT, and also now USDOT has recently released even more data that can be combined. But this is the Justice 40 data that we looked at, and we've done, in the interest of time, I guess I'll have to go a little faster. Oops. Okay, so I won't go into the technical details of this, but we are looking at, okay, what is the poor mental health prevalence in our southeastern region, and then these are just rural tracts, okay, and the cost burden. And we are looking at models where we are looking at poor mental health. I will skip some of this. Poor mental health prevalence and its impact on traffic fatalities in the southeastern census tracts. So this is the framework here. This is the independent variable, and then we are looking at a measure of transportation safety, and then also looking at the cost burden, how poor mental health is related with the cost burden in the database. So this is just work that we are doing right now. And in addition, now I want to point out a few small things. One is that, maybe 25 years ago, well, in 2001, when I was at Chapel Hill, we started to think about rural sustainable mobility. And this particular project was envisioned for Ford Motor Company, and they never funded us. But we thought that, these rural contexts provide us with a lot of opportunities for looking experimentation, because there isn't that kind of infrastructure that kind of inhibits you from doing leapfrog type technologies. So the CR2 C2 project 1-1 has been, it's Venkatesh and colleagues are part of this, and Nagarajan and Jerry is the leader. But I've been thinking about how to use some of these leapfrog technologies, and within the context of ACEs and the framework that I had shown to you, but looking at what are the new things, like, causal AI, for example, is mentioned here in this hype cycle. So hype cycle is a very interesting, you can go online and type in Gartner hype cycle, and every year they kind of update this. So they say, well, okay, there's an innovation and new technology, people think about it, then they have inflated expectations about that technology, and then there's this trough of disillusionment that they say, oh, well, we thought this would work, but it doesn't work, doesn't do as much as we thought. And then there's the slope of enlightenment and the plateau of productivity. So it's a kind of an interesting way of thinking about it. It identifies new technologies that are on the horizon. And we thought that maybe in this rural context, and Jerry developed this framework, we are looking at autonomous vehicles, of course, and but as in rural contexts. But can we think about leapfrog and how these technologies can really leapfrog some of the, infrastructure that might be needed in other contexts. So we've been doing literature review on this, and one way to kind of do topic extraction and link analysis is by using text mining, and that's what we've been doing. Then you can do all kinds of word clouds and so on. So I won't go into the details of it, but we've been analyzing literature in this way, and then developing, just to kind of show you, we've been developing the physical infrastructure layer and seeing, okay, what are the issues? And this maybe applies to other projects as well within CR2, C2, but all the way to, let's say, thinking about power supply and how people would need power supply for it to be reliable, and especially if you are putting in roadside units. It could be as simple as rural interstates where you take an exit to Buc-ee's or some of the folks that might be selling gasoline, and we could think about, okay, how do we support traffic signals in such context? Similarly, you can look at roadway infrastructure sublayer and how that works. So I showed you a lot of those variables underneath each of this. So that's what we've been looking at. And digital, how does the digital infrastructure layer look like? The availability and the accuracy of GPS systems, software, cybersecurity systems, so on. And also the regulatory and legal layer, which needs to be, this is kind of like stakeholders and how we need to have laws that are supportive and technology ecosystems that are supportive. In addition, we think there might be a cultural layer as well to this whole thing, like the political and government support, public interest and acceptance, education and training, emergency service preparedness, and economic considerations. Those are all that need to be addressed. So it's a complex set of framework that we need to, and ideas and also stakeholders, and being able to convince them that there is value in this experimentation and also implementation and deployment. Okay, so that's just we're also struggling with what infrastructure readiness means, looking at road quality, traffic control systems, connectivity, weather preparedness, and so on. So what are the thresholds? What are the metrics? We've been looking at that, but our framework does provide us with a good starting point. We hope to make more progress, especially with this data on disadvantaged communities and so on. We should be able to address these issues in a more substantive and holistic way. So I think that's all I had. I hope I haven't gone too far.
Thank you. Thank you so much. Okay, thank you so much. So I think the folks that are here, hopefully we're gonna have a little bit more time for conversation, but I would like to give the opportunity to the cyber side, if there is any question on the cyber side.
Yeah, thanks for the insightful thoughts. I was curious about that study about where we looked at crashes with a disadvantage index. So how were you able to distinguish people who were just maybe passing by an area which is disadvantaged versus who lived there and had a crash there?
So this is an excellent question about, okay, like where's the residence of the person who gets involved in a crash? My colleague, Dr. Chris Cherry, has done research on this topic of where the person lives. My understanding of it is that most of the crashes are within a close proximity of the person's residence, but it depends on the area or the state. If it's a lot of people are coming and going into that state, that is for maybe recreational purposes, then usually their home is outside the state. And that would be an interesting research issue to explore as to, okay, the crash happened here, but the crash happened in North Carolina, but this person was visiting from California. And therefore, you have a complex kind of a situation where you look at the actual location. And so the idea is that, most of the impact, the contributing factors, a lot of them are local. But yeah, I mean, the residents can make a difference as well.
Great. So before turning to one question inside the room, is there any question on the cyber side?
Yes, Dr. Ramayfar, go ahead.
Okay, Dr. Khattak, very informative talk. Thank you so much. I have two questions from you. One is early on about the first part of your talk, you mentioned something that I'm very peculiar and interested to know. You distinguish electric vehicle infrastructure from physical infrastructure. And I thought that the two are part of the same thing. And why so?
So that's a great question. And the reason I was trying to give it a separate category, there's a conceptual reason and then there's a practical reason. Conceptually, a charging station is both physical as well as digital infrastructure. So it doesn't nicely fit into one or the other, it's combination of the two. So I gave a separate category to that for a conceptual reason that they do represent infrastructure, but there's also like a physical infrastructure. You have to be able to go and park your car, but there's also digital infrastructure that's needed for that. So that was one reason. The other one was that at a policy level, we do want to look at this issue separately in the sense that it enables the transition to a different way of propulsion. And that, I think, given the amount of funding and also the amount of interest in alternative fuel vehicles, and especially movement towards away from the fossil fuels, I think that this presents a particularly different kind of a challenge. So therefore, it should be treated as a separate entity, and that's why I put it as a separate one.
Okay, thank you. My second question is related, since you presented a lot of survey, imagine that if you give the same survey in one state versus another state, there are a lot of biases. How do you remove the biases from one versus the other? Give you example, Tennessee versus California. The same survey that you give in Tennessee to people in California, I think you're going to get two different results in most of the questionnaires that you had.
That's right, and what we tried to do that was by providing, as much objective questions as we could ask. So the opinion questions were not asked in our survey. So in some sense, we can always say, okay, does your city have any effort on improving traffic signals or traffic signs or for making them compatible with CAPs? And so there's some kind of objectivity there. The one that was very subjective, we removed. That was the policy and regulation part, where people have a lot of different opinions. So we think our survey is replicable in other states because we explain what is what is it that we are asking, and we asked objective questions. Now, there's some subjectivity, as you are saying, in these questions, but we try to follow the survey research principles and try to make them as objective as possible within the context and framework that we were dealing with. So
Great,
I hope
thank
that
you.
answers your question.
Thank you.
Thank you. So there's one question over there.
Yeah, that's wonderful. I think I'm gonna have a lot of reading to do. All your papers are very interested. My first question, I think, is related to the one, because I was thinking in terms of assessing readiness, everybody's opinion might be different. So I think you answer that, like you try to use more objective measures. So that's that. Like I said, I'm gonna read more carefully about the paper. The second one is about those disadvantage indicators. Are they mainly from the census data, or where did you get those data from?
Which one?
The disadvantage to the community, you have a lot of indicators.
Right, so that's federally available. It's available online. It's called Justice 40 data.
Is it from DOJ or is it
So
from
it's,
the
yes, US Department of Transportation released this data, and it is very rich data, actually, I think. And we, they have now newer iterations of that data. So, the one I showed you, we started analyzing it 2 years ago, or however long ago they released it. Now they have a much better one. And
Sure.
today we were looking at with Venkatesh, we were looking and we found that they've enhanced it even further. So they are they are improving it, but yes, it's US DOT, it's publicly available. The website is called Justice 40, and you can just download the data.
All right, one last request. Do you want to share your presentation with us?
Sure.
Thank you.
Okay, thank you. So any other question from the cyber side?
Yes, there's one more question. I am afraid I'm going to mispronounce the name, but go ahead. Lakshmanan?
Yeah, hi, good
Yeah.
afternoon. I have a question on the communities. So what would be the overlap between the rural communities and the disadvantaged communities? As we know, the disadvantaged communities from the Justice 40 data, like what would be the overlap between this rural and the disadvantaged in the terms of technological readiness?
So we are not defining them in terms of technological awareness. So rural communities are identified by, the population and the size. And we have rural versus urban. There's many gradations in between, but roughly we say, okay, 20 million people live about that much in rural areas. Those areas, some of them, if you use the lens of disadvantage versus non-disadvantaged, some are disadvantaged, some are not disadvantaged, according to the criteria that I was showing you, the 5 different things: transportation disadvantage, environment disadvantage, and so on. So a rural area could be a non-disadvantaged area or a disadvantaged area. In terms of technology readiness, I don't know, maybe there is, we can look at so that's where the issue comes in. I was looking at small towns, and if they qualify as rural areas, then, and if they have, let's say, a plan for their city ITS architecture plan, intelligent transportation systems architecture, then you have more data on, okay, what do they have? And there used to be a federal survey they used to do on where the ITS technologies are deployed. So we are hoping to look at some of those, but really very little data in terms of on technology side in this disadvantaged communities part. They don't have a lot of information about technology.
Yeah, thank you for your answer.
We can take one last question from the cyber side, and then we adjourn, and those that are here, feel free to continue the conversation for a few more minutes. But one last question from the cyber side, if any?
No, I do not see any raised hands. please share your thoughts, comments, or questions about the presentation in 3, 2, 1.
Great, thank you so much. Let's thanks to the speaker again and thank you.